Well, welcome to another lesson for a quick review before the test. Hopefully this will be short and sweet. As you can see, I have a projectile motion problem set up on the paper in front of you. I tried to do a little color coding so you can see what everything's going to be. Hopefully this will all fit. In the end, we want to find out what the final position is in the X and the Y direction, as far as that goes. So we'll figure that out. We also need to fill in all these blanks. And you see there's more than one way to do some of these. This all begins with our initial relationship on vectors, which is r squared equals x squared plus y squared. X, of course, is r cosine theta. Y is r sine theta. And theta could be figured out if you take the arctangent of your y component and your x component. Assume you knew this. In our case here, since we're dealing with velocities, it will be the velocities that determine this. So hopefully this will all work out. And let's give this a shot and see how my new recording machine works here. First of all, velocity is in 100 meters per second in the angle of 30 degrees, which means what percent of it or what part is Vy. So we want to figure out this Vy component here. This Vy component is what? Well, I go 100. So turn this on, doesn't it? 100 sine 30, and it tells me that it's 50. So this is 50 meters per second. I do this again, 100 cosine 30, and it gives me 86.6. So this is 86.60 meters per second in this direction. Now that becomes my initial velocity for the beginning of the problem at 30 degrees. Now we're going up to 50 meters per second. I can use these formulas here, which you probably recognize from the old flashcard sort of thing of there's your average velocity, there's velocity final, which also could be solved for t, and if you think about it, this is delta v over delta a. This is also acceleration, because acceleration is delta v over delta t. We have your quadratic version, where you have distance final is 1/2 at squared plus velocity initial d. If this is 0 and that is 0, then you can use this shortcut, which I have up there. We also have our time-independent equation, velocity final equals initial plus 2ad. I can solve it for d. Well, since we know that the velocity at the top is 0, and we start at 50 meters per second, I can use this to solve for d. Go here. Velocity final at this point is really 0, because it's going to go from 50 to 0 on the way up. So 50 squared, or actually 0 squared, minus 50 squared, divided by 2 times negative 9.8, and that doesn't look right because it probably has a. So let's see, let's write 50 squared divided by 19.6. If I drop it all out, yeah, 127.55. So if I were to do this with the brackets, it would be quantity 0 squared minus 50 squared divided by bracket 2 times negative 9.8 in bracket. That way does that. And I get the same 127.55 meters up. I could also go for what is the average velocity here. Maybe Vy average. 50 to 0, average is 25, so this becomes 25 times time up, which I don't know yet. So that's not going to work. So I need to figure out time up. Well, I could do this for time up, velocity final minus initial, right? So it would be 0 minus a minus 50, or minus 50, right? Divide by negative 9.8, 5.1. So this is 5.1 seconds. I could then put 5.1 here times 25, and I get 127.55. The point I'm trying to make is you can do some of these things more than one way. Let's double check that our time up is correct. if distance is 127.55, which we're pretty sure of, times 2, divide by 9.8, and afterwards I take the square root, I once again get 5.1 seconds. So I've gotten 5.1 seconds twice. I've gotten distance two different ways. I can even do the velocity average, which I did earlier, which was 50, or 0 plus 50 over 2 equals 25, which is what I put in there. So at this point we know our time up, our time down, or not our time up, our distance up, and our velocities. Now let's work on the way down. Well, the tip down is 150 larger than the trip up. So I could go with distance is distance up plus the extra. So 127.55 would be the distance up, but it actually would be the distance down. So it's a negative 127.55 plus the negative 150 gives me, it's a negative 277.55 down. Now I can take the absolute value and go 277.55, so I don't have to worry about minus sign stuff. The distance I could also figure out for the average velocity, but I don't know the average velocity coming down yet, so this one's not going to work yet. Velocity final, I don't know the time coming down yet. I can figure out the velocity final because now I know the distance coming down, so it starts off at 0. So this would be 0 plus 2 times negative 9.8 meters per second squared times a negative 277.55 meters. And this is going to give me meters squared second squared. So I get 2 times negative 9.8 times negative 277.55. That number is VF squared. Take the square root, and I get 73.76 meters per second is equal to Vy final coming down. It actually would be a negative coming down as far as that goes, because this way's up, that's positive. Now, with that, could I then try to figure out my time down? Yes, I have my velocity final right there, 73.76, minus my initial, 0, the right buttons, divided by A, which is 9.8, and we'll ignore all the minus sign stuff. And once again, I get, type something wrong. So 73.76 minus 0 is, divided by 9.8 is 7.53 seconds down. We can double check it with this up here. 2 times 277.55. Yes, I've lost the minus sign because I'm dealing with the radical here where I have my square root. Remember, this is a square root. Divide by 9.8. Take the square root. And you get, once again, 7.526, which we're going to call 7.53 seconds. So once again, I've gotten the time two different ways depending on how I wanted to do it. Now, since I know this, the average, the 73.76 is the velocity final, I can add to 0, divide by 2. This gives me an average of 36.88, multiplied by time down, 7.53, and I should get approximately 277. In this case, we have 0.7, but that's because of the rounding of this. So once again, the answers are consistent themselves. What angle did it come in at? Well, the angle, the velocity y final is the 73.76 negative velocity y x. It never changed. It was 86.6 at the beginning. It's going to keep going across 86 point the whole time because there's no friction. So I can just plug that number in, and I get this. So if I were to put second 10 of negative 73.76 divided by 86.60, it's going to tell me negative 40.42. what that is saying is when I have my Cartesian coordinates, this is 0. I'm going to be 40 degrees, 0.42 down, as far as that goes. Now, how high up would I be from the bottom the other way? See, if I do this as second 10, 73.76 divided by 86.80, I get 40.42 upward. So yeah, it's doing that. You have to keep track of it. So it's actually telling me this is the 40.42. It's telling me the negative. That means that instead of being pointed this way for up, I'm pointing that way for down. So we kind of want to ignore that because I was right and wrong. You got to keep track of the quadrants. 1, 2, 3, and of course 4 over here. In the rules, this one has a negative y, a positive x. This one is a positive y, positive x, positive y, negative x, and this is, of course, negative y over negative x. Now we figured everything except dx, which is going to be equal to velocity x average multiplied by time total. My time total is, let's do that here, time total is the time up plus time down, which is, time up is 5.1, time down is 7.53, add them together, 7.53 plus 5.1 gives me 12.63 seconds. So I go 12.63 seconds here, multiplied by the average velocity in the x direction, which is 86.60 times 86.6. And this tells me I went 1,093.76 meters. As you can see the calculator. And I'm just rounding off 2 decimals because we got to round off somewhere. This is a non-symmetrical trip, as you can see, but this is about as hard as it can get. Some of the problems I'll give you in the test, I might give you these pieces, and you have to work your way backwards. Does it really matter if you go left to right, right to left? Draw yourself the picture, draw out what's going on. If you need to make yourself some cards to put on your book cover so you have the relationships handy, or draw yourself a prototype like this, and then you just fill in the blanks. And good luck on the test, and I'll see you Friday.